Strengths are asked in almost every coding interview, from Amazon to Google, but most people skip the basics and get stuck. In this video, I'll cover everything about strengths in DSA, from sketch to interview level, with real examples. Let's go. So first we'll define a string. So string is equal to let's say hello. So string think of a string like a row of boxes and each box holds one character. Here, string is a built-in class from the STL. S is the variable name, and hello is the text which we want to print it as a string. So for printing it, we can simply write C out, then these angular brackets S. That is a variable name. Let's run this and see. We got it to pre-printed. Now let's take the input from the user. So instead of hard coding this string, we'll just say string s. So we haven't given any value to that, we just have defined that s is a string data type variable. Now we'll take input, so for that we'll write cns like this. And we can even print a message. So enter. The semicolon should be removed. Yeah. So it's asking to enter something. Let us say InfoSmart. So you can see InfoSmart got printed. But like if we write here InfoSmart solutions, then you see again we got InfoSmart to be printed instead of the full name. Why is it so? Because it's the property of CN that it takes only the characters until we reach one space. So here we got space between InfoSmart and solution, so it only took InfoSmart and it printed that. To resolve this issue, we have getline, so we'll write getline and in parentheses cn comma s. If we run this, and it's asking to input, and you can see we got InfoSmart solutions. That is the whole sentence which we say. If right, we are in a lecture. So you can see we got the whole sentence to be printed as it is. Now let us see if we want to calculate the length of the string, then what we can do. So let us just remove this. Yeah, here we'll say s dot length. So it's basically a built-in function, and here s dot size. So and I haven't defined the string here, so error will come. So here let's say it is hello world. Uh, this should be and L, otherwise the both results will be in the same line as we can see. Yeah, now we got 11. So both gives the same answer, that it just calculate the characters in this. So you can see hello 5, then a space and world 5. So 5 plus 1 plus 5, which is 11. So we got the correct answer here. This is basically the string length. Next is indexing, if we want to like access any character in the string. So if we talk about indexing, then the first letter or the first character of the string is given index 0. So H is at index 0. Talking about E, it is at index 1. This L, the first one, is at index 2, and so on like this. So 0, 1, 2, 3, 4, 5, 6. So W is at index 0. So let us say that we want to print maybe the sixth index character. So you can see we got W as our output. Now we can do one more thing. We can write s dot at 6. So if we I have given end line to, so it will come in the same line. Yeah. So we got W from s dot at also, but what's the difference between both of the methods? So square bracket indexing is fast, but it's dangerous because if we go out of bounds, then our program crashes silently. But if we use dot at, then it will throw a error. Like if we say if we write here 20, and here also let's write 20 and just run this. So you can see we got 0, but 0 is not written in our string. So what happened? So just gave us the wrong output. Now if we try with dot at, then you can see it gave us a error. So that's why dot it is preferable. Now the next thing is to traverse over the string. So for that, talking about the first method using for loop, which is for int I as 0, then I should go till the length of the string. So s dot length and I plus plus because it should be incremented by 1 every time. And here we'll just print the each character. So I is basically our index and it will go from 0 to the length of the string. And when we run this, we got this hello world. Now if we write a end L, you can see it clearly that every character is printed in different lines. Uh, it gave us an error. Mm, yeah, so I don't know what was the error, but now when I run it again, it worked well. So hello world, you can see every character printed in different lines. Now the another method is to write char c. C is basically a variable name and char is its data type, that is it's a character, and char c colon s is our string, and we'll just print c like this. Mm, yeah, so running this again, we got the correct output hello world. Then here again with other loop hello world like this. Now the next thing is to modify the characters. Like if we say that this H should be capital of hello, so we'll write S0 is equal to, and as a character, because we have given single quotes, we write this and then we'll print the string. So H got capital. Now the next thing is substring, which is very useful if you are doing lead code type questions. So in substring, we basically find a certain part of the string using the built-in method of substr. So let's say we need to print s dot substr and we want only hello to come. So if we see it's starting with index 0. So first we'll write the starting index and then we'll see how many number of characters we want. So hello is of 5 characters, so we want 5 like this. And secondly, if we want that world should be there, so here we will write the starting index of w, which is I suppose 6, and then we do not have to give anything, it will just automatically take it to the last. Like if we don't mention, then it will assume that it has to go till the last. Mm, what did it print? Okay, okay. I haven't written here end L, and that's why. Yeah, so you can see we got this hello and world here. So from the first line we got hello, and from the second line of code we got world. Now the next thing is find. So here we'll write s dot find and whatever we want to find, like world. And let's say we also need to find something that is not actually present in this. Let's say XYZ. So you see, we got the correct result for world, but for XYZ we got something that's not needed at all. So for this, what we can do is we can simply write C out, sorry, we can write if s dot find XYZ is equal to string colon colon and pose, then simply print not found, and we can comment this. So it is basically that if that particular string is not found in our original string, then you'll just have to compare it with this. If it's equal, then it means it's not found, and then we can print anything we want. So let's see. So you can see in first we got world 6 because it was starting from the sixth index, and second XYZ is not found. Now let's see if we print let us just duplicate this world, hello world, like this. Yeah. And here we say our find world. So our find basically searches from the right. So it is the last occurrence of the substring. If we see here, then it printed 0 for our s dot find because it started from this end and it got world at once. So it printed 0. And talking about this R find, it looks from right and goes to left. So here 12 means that it just start from here, then it got that world is written here. Now it will see that this world is started with this W, and so we'll count this is fourth index, then this one is 5, then 6, 7, 8, 9, 10, 11. And so this W is the 12th index, and that's why it has printed here 12. Next thing is erase. So let us say here to erase from, let's say, 5 comma 5. So basically it will start at index 5 and it'll remove 5 characters. Uh, why did we get D here? So we got D because it started from the fifth index, and 0, 1, 2, 3, 4, 5. You can see that this is the fifth index, that is this space, and started with 5 characters. So 1, 2, 3, 4, 5. So 5 characters are done like this. So we should have started with sixth index, should remove world from this. Let us run again. So you can see we got hello. So now the next thing is to insert something, and let's say it's this hello world, and we want to insert, let's say, space at the fifth position, which we just removed. So we'll write here like this. So insert just takes an index and a string to insert at that position. So you can see we got here hello space world. Now let's replace a portion. Let's say s dot replace, and we write 5 comma. So first is to where to start. So we are starting from the fifth index, and then is how many characters to remove. So we'll remove 5 characters. Let's remove world. And then the third one is what to put there instead. So we'll put there info smart, and it should be in double quotes. So let us see the result. So you can see we got hello info smart. Now the next thing is to append. Let's say our string is hello and we want to append world to it. So this way we can add something to the last of the string, and we got hello world as a result. So it's basically append is the same as using plus equal to, because we can write even plus equal to add to strings. Like if I say see out hello plus world and just comment this. So we can write a string and like this. And using this, we can add this hello world. Or we could have done like writing above string is hello, string B is world, and then C out A plus B like this. So we would have got this hello world. Now next thing is pushback. So if we wanna add a little like it's hell and we want to add O, then we can simply write s dot pushback and then here O, and simply will print a string. A semicolon is required here. So pushback adds a single character to the end of the string. Now if we see pop back, then simply we'll write here pop. So it removes the last character. No arguments are needed in this. So you can see we got HEL. Now, if we want to check if the string is empty or not, let us make this hello, and now let us see if s dot empty. Empty means that there's no character in the string. So in this we have the character. So we'll say if s dot empty, see out string is empty, and other thing will say else see out string is not empty. So if we see this, we got string is not empty because we have this hello. Now if we just check this one, we got string is empty. And this s dot empty is similar to checking if s dot length is equal to 0 or not. Like we can put even this condition instead of putting this empty. Now let's see how to reverse a string. So if we have hello here and we want to reverse it, then simply we'll write reverse, then we'll write s dot begin if we want to reverse it from the beginning, and s dot end till the last. Then we'll just simply print the string, and we should get okay. So for using reverse, we want to have to include algorithm. So here we'll say include algorithm. Now we can run this, and we got OLLEH. That is the reverse of hello. Now if you want to sort, then simply you can write here sort. That is, it will sort all the characters alphabetically. So we got EHLLO. Now if we want to convert from string to integer, then we can use stoi. So let us comment this, or let us just remove this, and we'll say string s is equal to 1 through 3 4, and then int n is equal to stois, and then we'll put n plus 1. So basically this string will get converted into an integer, and that's why when we perform an operation like addition by 1, we get some integer value as our answer, which is 1 2 3 5. Now if we want to convert an integer to a string, then we can say int n is equal to 1 2 3 4. Then we can make one string which will be equal to string n. So here the built-in function we are using is toString. And now we'll print, let's say we add one exclamation mark to it. So we got here 1 2 3 4 and then exclamation mark, which says that this is indeed a string and not an integer. Next is checking if character is a letter. So we say here string is hello. We can iterate over this string and we can check if every character is a letter or not, or just to make it simple, let us just say to check if A is a character or not. Let us also check other things out. Maybe we can check one and a space. So first should be true and second and third should be false. So you can see here, because we haven't written end L, so we got values like this. So when it's true, we get a non-integer value, and when it's false, we should get a 0. You can see we got non-integer value because A is indeed a letter, and 1 in space is not a letter, so we got 0. Next is checking if a character is a digit. So instead of alpha, we'll write digit, and let's see. Oh, it remained alpha, but it's okay. So for the first one, we got for A, digit is 0. Then for 1, we got as 1 because 1 is a digit, and so we got a non-integer value. Yeah. So likewise, we can check that if it is a letter or digit both, if letter or digit. So for this, I'm just naming the function that is L is alphanumeric, so ALNUM. You can check it out yourself whether it gives a true value for letter digit or false for a symbol like this. Now let's move on to converting the case from like lowercase to uppercase or uppercase to a lower like this. So let us say we have this string, or better we take a character and we just change a character to uppercase or lowercase. So we'll write here char and here to lower c. So basically this will convert capital A into small a and it will print this. And this is a very simpler version. If we want to do for each characters of a string, then we can use a for loop. Let us say if we have a string hello, and then we say for char and ampersand c. We had discussed in detail about pass by reference and pass by value in the last video about this ampersand. You can go and check it out. And here we can just convert each character to lowercase using the. So it basically means that we'll iterate over every character of the string. So first h, then c will be equal to lowercase of that character which is h. So c will get a value of lowercase of that, and here we can print that c so that we can see here how is it changing the lowercase. So you can see we got HELLO in small. Similarly, we can use to upper to change it to or convert it into uppercase. Next, if we talk about size of, then size of is not the way to get string length, and this trips a lot of beginners, and that's why I'm telling this. So size of basically gives the size of the string object in memory, something like 32 bytes. Like if we just want to print s dot size of like this. Oh, sorry, it is. I haven't written C out. So we got 24 and not the length of the string, which is actually 5. Next thing is compare. If you want to compare two strings, like we say S1 is apple and string S2 we make as banana, and we say that we want to compare both, then we can simply write here S1 dot compare S2, and we can even say S2 dot compare S1. So when we say S1 dot compare S2, it will give negative if S1 comes before S2 alphabetically. I have to write end hill here. And the second one will give a positive answer if S2 comes before S1. Mm, what's the error here? I feel everything is fine. Yeah, now we got the correct answer. So S1 dot compare S2, this gave -1 because apple comes before banana alphabetically, like this. And if both the things are equal, like if we say this, let's remove other things. S1 dot compare S1 only, let's say. Then it means that both of the strings are equal, equal strings are compared. Then we got 0 as our answer. So in practice, we can use it like S1 dot compare S2. If the value is 0, then we print it equal like this. So above, like we read stoi, we also have stod to convert strings to double. Then we have other things like stol to for long. For float we have stof, and for long long we have stoll. But most of the times you will see that only stoi and stod are being used. Then we can see find last of built-in function. So in this, if let's say we have a string hello world full like this something, and we just print s dot find last of, and inside these let us say this slash we want to print, you see we got 11. So we see this one, this slash has index 5, then this one has index 11. So we got the last of occurrence of that. So find last of helps us to do this. Now let us see a few problems. First one is to check palindrome. So palindrome is basically like if we take a string race car and if we reverse it, what we'll get? So the last letters R, then A, then C, E, C, A, R. So you see, after even reversing this word, we got the same word as it is. So this is a palindrome. Let us say string S is equal to race car. And now, as I said that we just have to reverse it and we need to check if it's equal to the original word. So if we want to check it with the original word, first we need to store this. So we took rev as a random variable and just we stored the value of string in this. Now we'll reverse this. After reversing this word, we'll see if both of them are equal. So S and REB. So just reverse word and S. If both of them are equal, then we'll print it to be a palindrome. Else we can say that it's not a palindrome. Let us see the result. So we got a palindrome here. Now let us remove this and if we see we get correct answer, not a palindrome. So yeah, we got it correct. Now the next thing is to count number of vowels. So for that, uh, let us say we have a string s is equal to hello world, and then we'll iterate over this string. So for char c in s, if c is equal to a or c is equal to e or c is equal to y, like this we'll just write for every vowel here. C is equal to U. Here it should be single quotes as we are comparing a character. So if this is the case that A, E, I, O, U, one of them is there, then we simply increase count by 1. And so we need a variable named count. So we'll say int count is equal to 0. And at last we simply print the count. We can write here number of vowels. So here we are considering that all these are in small case. That's why we have written here AIU in small. Otherwise, we can convert each character in lowercase and then we can check, or we can take we can put more conditions here like capital A, capital E, and so on like this also. So number of vowels here we got as 3, and if we check E, O, O, yeah. So there are only 3 vowels. Now let's move on to the next question. It is a Caesar cipher problem. So this is the oldest pattern of data encryption used by Caesar, hence named as Caesar cipher. He used this to send secret messages to commanders. In this, he shifts all the alphabets by few counts, say 3. So if I consider alphabet A, then it will be converted into D, because when we shift 3, it will be A to B, then B to C, then C to D, like this. So by a specific number, it will shift all the alphabets, and this is how he used to encrypt the message. So we'll make here a function string caesar encrypt, and inside this we'll take the parameters string text and int shift. So first one is the text that or the message that we want to enter, and shift is by how many positions all the letters should shift. Then inside this we'll iterate over our text. So for char C in our text, and we'll check if it is uppercase, then we have a bit different condition than what we have in lowercase. So is upper C, and what condition we have in this is, we'll just say C minus capital A plus shift. So basically this will take its ASCII value, and accordingly we get our correct shifted alphabet. Here we'll write if it's lower, then C is equal to C minus A plus shift this whole. We'll see the remainder with 26 plus small a because it's the lower one. And then we'll return text. So we created this function of Caesar encrypt, and uh, this main class is not here. Yeah. So here we'll write in main that string message is equal to hello world. Let us make this capital, and this also let us make capital some random words letters, and then we'll say that int shift is 3, and we want this function to work on message and shift, that is message and shift are our arguments. So let's see, and we got this. uh, we want it to shift, but we only got H as K. Other letters are not encrypted. Yeah, so we returned text wrong here. We should have returned it here. Like after this for loop is over. Otherwise, it will just iterate once and we returned the text. So it came back to this main function and we got here the result. That was the problem. So here you can see our message got encrypted and we got some alphabets here, which is not the same as the message we input. Now the next thing is to check anagram. Okay, so let us say string. So anagrams are words that contain the same number of letters. Like every letter with its frequency, it should be same. So if we take here, and let's say listen, and the second string is silent. These two strings are there. Then we just have to sort both of them and we need to compare. So sort the first one, s1 dot end, so from starting to the end. And similarly, we can sort the second string. Then we'll say if s1 is equal to s2, then we need to print anagram, else not an anagram. There's some error here. Mm, okay, I haven't put in a semicolon here, that's why. So we got the correct answer, which is that it's an anagram. Now, a common mistake to avoid, like sometimes what we do is let me write and then explain. So if I say that string is hello, and I say that for character C in S, if C is equal to L, then just S dot erase S dot find C comma 1. So what we are doing here, we are just finding the index of C. And what is C in this? It's L. So we are finding the index of this and we're erasing that. So we're erasing that particular letter L. So what we're doing, we are modifying it while iterating. We are iterating of the string and in the same time we are modifying it. So it should not be done. We should never modify a string while looping through it because the loop does not know the string has changed and its internal pointers get confused and we might get wrong output or the program may crash. So it's always better not to modify while looping. So that is everything you need to know about strings in C++ for college exams, competitive programming and coding interviews. If this video helped you, hit like and subscribe. I'll see you in the next video. Till then, stay tuned and happy coding.